Hey everyone, ready to jump into some seriously cool AI stuff.
Always up for that.
All right, so someone wanted us to do a deep dive into this UltraMem research paper.
Sounds challenging.
Yeah, and I gotta say, even just skimming through it, my brain kind of went into overload. There are some crazy visuals in here and some numbers that are like seriously mind-boggling.
Well, that's where I come in, right? I can help us unpack it all.
Exactly. You always manage to explain things so clearly even when it's super complicated.
I try my best.
Okay, so maybe before we get lost in the technical jargon, could you give us like a super quick ELI5 version of what a language model even is?
Sure, so imagine like a computer program that's read everything on the internet. Every book, every article.
Okay, I'm picturing a super-powered bookworm.
Yeah, kind of. That's essentially what a language model is. It's learned all these patterns and relationships in language, and it can use that knowledge to do things like write text, translate languages, answer questions, you name it.
That's incredible. But I bet all that learning takes a ton of computing power.
You got it. These models can be massive, with billions, even trillions of parameters. That means they need a lot of energy and resources to run.
Aha, so when we talk about efficiency in language models, we're basically saying we want them to be lean and mean, right?
Exactly. We want them to be as powerful as possible, but also use resources responsibly, especially if we're going to use them for things like real-time applications on our phones and stuff.
That makes totally sense then. So now let's get to the heart of this deep dive, UltraNem. This paper claims it's faster and more efficient than the current top dog, which is mixture of experts, or as the cool kids call it, Mo-E. So what makes Mo so slow in the first place?
Well, think of it this way. Imagine MOE is like a giant library, right? And it's filled with specialists on every topic imaginable.
Okay, I'm following. Lots of experts, lots of knowledge.
Now, let's say you have a question, a complex question that needs input from several different areas. In Mo, it's like you have to run around to all these different specialists scattered throughout the library to get the info you need.
Ah, so it's all that running around that's slowing things down, kind of like a logistical bottleneck.
Exactly. All that back and forth creates a bottleneck that slows down response times. And it's not very efficient.
Makes sense. So UltraMem is basically saying, hey, there's a better way to organize all this knowledge.
Yeah, that's the core idea. Instead of activating all these different experts for every single piece of input, UltraMem uses a massive but super sparse memory layer. It's like having a super detailed library card catalog that points you directly to the exact information you need.
Wow, that sounds way more efficient. No more running around like a headless chicken. And I'm looking at figure 1 in the paper here, and they're claiming UltraMem is up to 6 times faster than Mo.
Right, and they even have those nice graphs that really drive the point home. You can just visually see the difference.
Yeah, those visuals definitely make it easier to grasp. Okay, so how does UltraMem actually work? They have this diagram of the architecture in figure 2, but honestly, it's kind of intimidating. Can you break it down for us?
So imagine that every piece of information in UltraMem has its own unique code, kind of like a product key.
Okay, every bit of knowledge has a barcode. I can visualize that.
Right, now imagine all these product keys are arranged in a massive 2D grid, like a giant spreadsheet. And when you give UltraMem an input, it generates something called a query.
The query is like what you're searching for.
Exactly. And UltraMem has this really clever algorithm that matches the query to the most relevant product key in the grid. It's like, boom, instant access to the exact info you need.
No more running around the library, just straight to the source.
Pretty slick.
But hold on, they didn't stop there, did they? They added a bunch of extra tricks to make UltraMem even more powerful, right?
Oh yeah, they went all out. There are a few that I thought were particular about interesting.
Hit me with them. What kind of tricks are we talking about?
Well, one is that they double the number of values while having their dimension.
So instead of having one giant general encyclopedia, you have a bunch of smaller, more focused books on specific topics.
You got it. It's like they're giving the model a wider range of more specialized knowledge to work with.
That's clever. What else?
Another one is they split that big memory layer into smaller units and spread them across different layers.
So it's like having multiple branches of a library instead of one giant building. Distributes the information better.
Exactly. Then there's this technique called Tucker decomposition, which is a way of breaking down a complex problem into smaller, more manageable pieces.
It's like solving a 3D puzzle by breaking it down into those simpler, flat pieces, right? Easier on the brain.
Yeah, exactly. And finally, they use something called implicit value expansion. This is a way of virtually expanding the memory size without needing a huge increase in computing power.
Wait, so they're basically making more storage space appear out of thin air. How is that even possible? It sounds a bit like magic. Did they actually prove that all of this works?
They did. They did a ton of testing comparing ULTRA-LEM to both MOE and the standard dense models. And they used some massive data sets like Red Pajama, which has over 1 trillion tokens.
A trillion. Okay, now that's a number I can't even wrap my head around. So how did UltraMem stack up against the competition? Did it live up to all the hype?
It definitely did. In fact, there's this one result in Table 1 that really stood out to me. They showed that on a 1.6 billion parameter dense model, UltraMem, with 12 times the parameters, actually matched the performance of a 6.5 billion parameter dense model.
Whoa. So it's like getting the same power from a tiny electric car as you would from a giant gas guzzler.
That's a great way to put it. And in section 5.3, they went even deeper, analyzing the trade-off between sparsity and performance. Figure 6 shows that UltraMem's speed stays super consistent even as the number of parameters increases dramatically.
So it's not just faster, it's also way more scalable.
Exactly. Which is exactly what we were hoping for, right? Speed and efficiency. Looks like UltraMem delivers on both counts.
This is seriously impressive stuff, but I have a feeling we're just scratching the surface here. There's so much more to unpack in this paper.
You're right, there's still a lot to unpack. One thing that really caught my eye was how much the researchers focused on these scaling laws of UltraNem.
Scaling laws. Okay, that sounds a little bit intimidating, like some secret code of the AI universe.
Aha, not quite a secret code. But it is a pretty big deal in AI research. Basically, scaling laws tell us how much a model's performance improves when you make it bigger and give it more data to learn from.
So the bigger the model, the more data it eats up, the smarter it gets.
That's the basic idea. But here's the thing. Different models, different architectures, they all scale differently. Some models, they hit a ceiling. You make them bigger, but they don't really get much smarter.
They get full, like they've had enough dessert.
Yeah, kind of. But other models, they scale more smoothly. They keep learning and improving as they grow.
Okay, so where does UltraMem fit into all of this? Is it a picky eater, or is it one of those models that just keeps getting smarter?
Well, that's what makes this research so interesting. The paper suggests that UltraMem scales really well. Like, really well. It doesn't seem to plateau like some other architectures.
So it's like a model with an insatiable appetite for knowledge, constantly growing and evolving. That's kind of awesome.
Exactly. That's one of the big takeaways here. UltraMem might be able to reach a whole new level of performance because it can break free from those traditional scaling limits.
Okay, so we've established that UltraMem is fast, it's efficient, and it scales like a champ. But let's zoom out for a second and talk about the practical stuff. What does all of this actually mean for us, the everyday users?
Well, think about all the ways we use language models right now. Chatbots, search engines, those translation apps we all rely on, voice assistants, all that stuff.
Okay, yeah, I use those every day.
All of those applications could get way faster, way more powerful with something like UltraMem under the hood.
So we're talking about like lightning-fast search results, chatbots that can actually keep up with a conversation, and translations that are like practically flawless.
Exactly, but it goes beyond just performance. UltraMem's efficiency could also mean less energy consumption, which is a big win for the environment.
Oh, wow. So not only would our AI be smarter, it would also be greener. I like that.
Right, and this efficiency also means we could potentially run these super powerful models on devices that didn't have a ton of resources, like smartphones or even those little smart home gadgets.
Wait, so we could have super smart AI running on our coffee makers. Now that's both exciting and a little bit terrifying.
Maybe not our coffee makers just yet, but the possibilities really are pretty mind-blowing. This technology has the potential to change how we interact with AI in a big way.
Okay, so it all sounds amazing, but I gotta ask, are there any downsides? It feels like we're getting something for nothing here, which always makes me a little suspicious.
That's a fair point, and the researchers do acknowledge that there are some potential challenges. One is the complexity of actually implementing UltraMem. It's a pretty sophisticated architecture.
So it's not exactly plug and play, more like one of those high-performance race cars that need a whole team of mechanics to keep it running.
Yeah, good analogy. Another area where they need to do more research is exploring the theoretical limits of UltraMem's scaling abilities. Will it really keep scaling forever, or will it eventually hit a wall? Those are still open questions.
Right. Even in the world of cutting-edge AI, there's no such thing as a free lunch. There are always trade-offs and limitations. But even so, this UltraMem research feels like a huge step forward, like they've opened a door to a whole new world of possibilities.
I totally agree. It just goes to show how incredibly fast AI research is moving these days. Makes you wonder what other amazing breakthroughs are just around the corner.
So we've talked about the architecture, the efficiency gains, the scaling potential, even the potential impact on our lives. But there's one crucial part of this tape that we haven't really dug into yet: the experiments and the results.
Right, you can't have science without solid evidence, and this paper definitely doesn't disappoint on that front. They ran a ton of experiments using all the standard benchmarks to compare ULTRA-MEM to other models.
So they didn't just talk the talk, they walked the walk.
Exactly. They wanted to prove that ULTRA-MEM's theoretical advantages actually translated into real-world improvements.
Okay, so let's get into the nitty-gritty. What exactly did they test and what did they find? Give me the data.
Well, they tested ULTRA-MEM on a bunch of different tasks that are commonly used to evaluate language models, things like question answering, text summarization, language translation, even creative writing.
Wow, so they really threw the whole AI test suite at it.
Yep, they wanted to make sure it could handle a variety of challenges.
All right, so how did it do? Was UltraMem the champion in every category?
It wasn't always the absolute best, but it consistently performed at or above the level of the other state-of-the-art models. And remember, it did all of this while being much more efficient.
So maybe not always the gold medalist, but definitely always on the podium. That's still super impressive.
Absolutely. For example, they use this data set called Trivia QA for question answering, which is basically a massive collection of trivia questions and answers. UltraMem totally outperformed previous models on this benchmark, showing that it's really good at finding and processing factual information.
So it could be the ultimate trivia champion. Watch out, Ken Jennings.
Haha, maybe. Another task where it excelled was language translation. They used a benchmark called WMT, which evaluates translation quality across a bunch of different language pairs. And again, UltraMem achieved state-of-the-art performance.
Wow, so it's a multilingual whiz kid, fluent in every language under the sun.
Well, it's definitely on its way. These are just a couple of examples. But the main point is that UltraMem consistently delivered top-notch performance across a wide range of tasks, all while using resources more efficiently.
Okay, that all sounds incredible, but I have to admit my brain's starting to feel a bit overloaded. Can we take a step back and, summarize the key takeaways? What's the big picture here, and why should we be so excited about UltraMem?
You're right, it's easy to get lost in the details. So here's the TLDR. First, UltraMem could be a game changer in terms of efficiency for language models. It performs as well as or better than existing models, but it uses way fewer resources.
So it's like getting the same horsepower from a smaller, more fuel-efficient engine.
Exactly. Second, UltraMem scales incredibly well. Its performance just keeps getting better as you make it bigger and give it more data to learn from. No hitting those performance plateaus.
It's that insatiable learner we were talking about earlier.
Yep. And third, the researchers actually have the data to back up their claims. They did rigorous testing across a wide range of tasks and showed that UltraMem really does deliver.
So this isn't just hype and empty promises.
Nope, they've got the receipts. And that's why this research is so important. It suggests that we might be on the verge of a whole new generation of language models that are more powerful, more efficient, and more sustainable.
Okay, I'm starting to see the full picture now. But you know what? I think there's still more to explore in this paper. Maybe we can dive into some of those nitty-gritty technical details in the next part and try to understand how UltraMem actually works under the hood.
I'm game if you are. There's definitely a lot more to uncover in the experimental section.
All right, then let's gear up for another deep dive. We'll be back with more insights and analysis after a quick break. Okay, so we're back and ready to finish up our UltraMem deep dive. Before we got sidetracked with all those scaling laws, we were talking about the experiments that show UltraMem actually works. What really impressed you about those results?
Well, I thought it was really cool how much time they spent analyzing UltraMem's performance. They didn't just give us the overall scores and call it a day. They actually went deep and figured out how different parts of the architecture contributed to the results.
So they weren't just happy to show that it works. They wanted to understand why it's so good.
Right, exactly. For example, they looked into how the sparsity of that memory layer affects performance. Remember how we talked about sparsity? How it means only using a small part of the model's parameters for each input?
Yeah, it's like that super efficient library and card catalog that takes you straight to the right info.
Exactly. And what they found was that UltraMem is really good at finding this balance between sparsity and performance. It can activate a tiny fraction of its parameters without losing accuracy.
So it's like a master chef who can create an amazing dish using only a handful of ingredients. Minimal effort, maximum result.
Haha, I love that. It really captures the essence of UltraMem's efficiency. Fewer activated parameters means less computation, less memory usage, and ultimately less energy consumption.
Okay, that all makes sense. But what about those fancy tricks we talked about before, like doubling the number of values and all that? Did those actually make a difference?
Oh yeah, absolutely. They did what's called an ablation study, which is basically where you remove different parts of the model one at a time to see how each one affects performance.
So like taking apart a car engine to figure out which parts are actually necessary to make it run.
Perfect analogy. And what they found was that each of those tricks, like doubling the number of values, splitting the memory layer, using Tucker decomposition, and implicit value expansion, all of them made a big difference.
So it's like a perfectly choreographed dance, where each move contributes to the overall performance. No room for slackers in this routine.
Exactly. And what's really interesting is how some of these tricks actually address specific limitations of that original product key memory idea.
So they're not just bells and whistles, they're actually solving real problems.
Right. Like, for example, the original product key memory wasn't very good at capturing complex relationships between different pieces of information. But by doubling the number of values and using Tucker decomposition, ULTRA-MEM can suddenly understand and represent those relationships much better.
So it's like upgrading from a simple dictionary to a whole encyclopedia. More words, more connections, more knowledge.
You got it. And honestly, this is just scratching the surface of what they covered in their experiments. They really did a deep dive.
It sounds like they were on a mission to make ULTRA-MEM as powerful as possible. They weren't satisfied with just good enough.
Totally. It's that relentless pursuit of pushing the boundaries that really makes this research so inspiring. It's not just about coming up with new ideas. It's about testing them, refining them, and really squeezing out every ounce of potential.
I love that. It reminds me of those classic inventors who would just tinker away in their workshops for years, totally obsessed with pushing the limits of what's possible.
And speaking of pushing limits, this research raises a pretty big question. If ULTRA-MEM can achieve this level of performance with 12 times the parameters of existing models, what could it do with even larger models?
Woo, now that's a thought. It's like they've given us a glimpse into a future where AI is not just smarter, but also way more efficient and accessible than we ever thought possible.
That's exactly why this research is so exciting. It's not just a small step forward, it's a potential paradigm shift in how we think about and build AI systems.
Well, I think we've successfully conquered the ULTRA-MEM mountain. We've explored the inner workings, uncovered the efficiency gains, marveled at its scaling potential, and even pondered its implications for the future. My brain is officially full, in a good way.
Mine too. Always a pleasure to dive into cutting-edge research like this.
And to all our listeners out there, thanks for joining us on this incredible journey. This is just a tiny glimpse into the vast and constantly evolving world of AI. Who knows what other mind-blowing discoveries await us? We'll be here to break it all down for you, so stay tuned for more deep dives into the fascinating world of artificial intelligence. Until next time, keep those brains buzzing and your curiosity alive.